This short session will be looking at what a neuron is like. A single neuron has the following element. It has the input to the neuron, which could be from the input layer or from preceding intermediate layer, and it has an output which could output to the output layer or output to the succeeding neuron of the succeeding layer, and it has a set of weights based on the input that is being given. So each input has an associated weight. So essentially the weight is trying to learn how important is that particular features to the determination of the result or the output. So we are multiplying the weight with the input. So the weight of X, which is a feature, is W1. The weight of X2 is W2. So let's say, for instance, that W1 is 0. That means that X1 does not have any votes in the total result, because we are going to multiply W1 with X. So it doesn't matter what the value of X1 is, then W1 has already made it useless by being 0. It means it's not carrying any weight in the final decision. It's just like in voting system. If somebody does not vote, then the person is not carrying any input. It's not making any input. Okay, so it can be assumed 0. So these are the weights that we're trying to learn during training, during the forward propagation and backward propagation, as we shall see soon. Then we normally ask this bias unit W0 just to make sure that the vector is not always just starting from the origin. So as you can see, so these are the input values, and W0 is the bias term. So now to calculate our output here, we multiply each of the W with X with its corresponding input, and you sum it over. So that's why this is from 1 to n, and you had a bias. So for every neuron there is a bias. You add the bias, then you pass it through the result through a function. So this is what we refer to as the activation function. So this function could be linear or it could be a non-linear function. Generally, it's always use a non-linear collection of nodes where each node has an adjustable float value, and they are interconnected as a graph to return an output. So I've said this earlier. So in the next lecture, we'll be looking at what we do to be able to learn those weights, which I said they are numbers. So one of which is we do a forward propagation, then we estimate the loss based on the ground truth, then we do a backward propagation. So see you in the next one. Thank you.